Hello guys, welcome to Romta Solutions and welcome to your lesson on grade 12 physical sciences. Today we are looking at momentum and impulse, and of course we are specifically looking at Newton's second law of motion and momentum. So at the end of this video you should be able to use these formulas and also to be able to relate them. Okay. So now our video is structured in this way. We're going to, as usual, introduce the concept, why we're introducing it, and then remind you what Newton's second law of motion is. Thirdly, relate it to momentum, and then have some worked examples, maybe one or two. Okay. So without any waste of time, into it. So for our introduction and revision, let's remind you, we said momentum of an object is basically the product of the mass of the object and its velocity, right? So we symbolize momentum with letter P. So P equals mv, where P is momentum, m is mass, and v is velocity. Then we also spoke of change in momentum, right? We also spoke of change in momentum, which we will call, or which we called delta P, and it has the formula delta P equals mass m multiplied by final velocity minus initial velocity. So this v sub I is final velocity, whereas this v sub f is final velocity, and this v sub I is initial velocity. Okay, perfect. So you recall that we said in the previous video that F net is the reason velocity changes, all right? Is the reason velocity changes, all right? We said F net is the reason velocity changes, right? Now, it's okay. Since we said that, now we need to know, now we're going to calculate this F for F net. So how large is this F net? All right? And you recall, this is a force. We're also going to ask, how long does it act on the object? All right? How long does it act on the object? How long does it act on the object? So at the end of this video, you will be able to answer these questions. Okay, you will be able to answer these questions. How long does it act on the object? Okay, this is it. So let me wait for you guys to take down these things. At least 10 seconds for those that are behind. Okay, all right, moving on. So now we're going to remind you guys of Newton's second law of motion. Allow me to call it like this: Newton's second law of motion. All right, let's remind ourselves what this law was saying. This law was saying that when a net force acts on an object, the object will accelerate in the direction of the net force, but it doesn't end there. Okay, so let me write it. It's the definition. Let me write it in a different color. I'm sorry, I'm using a green color. When the net force acts on an object, object accelerate in the direction of the net force. In the direction of the net force. All right, in the direction of the net force. Now it doesn't end there. So it further says the object's acceleration is directly proportional to the net force. Okay. It says the object's acceleration is directly proportional to the net force. And it's directly proportional to the net force and inversely proportional to the mass of the object. Inversely proportional to the mass or to the mass of object. Okay, so I'm going to give you time again to write this down before we proceed. Okay. So we say Newton's second law of motion says when the net force acts on an object, the object accelerates in the direction of the net force, and the object's acceleration is directly proportional to the net force and inversely proportional to the mass of them. So check this out. We say there is a formula that we're getting from this law. It says the object's acceleration is A, is directly proportional to the net force. Okay. And again, inversely proportional to the mass of object. Okay, and inversely proportional to the mass of the object. Proceeding, this then says to us, F net is equal to ma. This is Newton's second law of motion. Okay, this is Newton's second law of motion, where this is the force, or i.e. net force. Maybe let me call it net force. All right, in Newton's, this is the mass of an object measured in kilograms, and this is acceleration. Remember, I'm not specifying what kind of acceleration. So this is acceleration, which is measured in meters per second squared, right? Which is measured in meters per second squared. Okay, so from this, we know 1 Newton, From this, we know 1 Newton is equal to 1 kilogram meter second squared. And remember, guys, force is a vector quantity, so it needs magnitude and direction. So whenever you do force calculations, you must state a direction you want to be positive. Okay, perfect. So let's proceed. We are now going to relate. Now we're going to say Newton's second law of motion and momentum. Newton's second law of motion and momentum. Right? And momentum. So by now you guys know what is momentum. So we are okay with that. We're not going to dwell much on it. So let me remind you, previously we said Newton's second law was saying F net equals ma. Now remember from grade 10, Remember, acceleration is change in velocity over change in time. If you like, you can say it is final velocity minus initial velocity all over delta time. Right? So, on this equation, I will say where there is acceleration, I will put this. So let's see. This becomes F sub net equals M V sub F minus V sub I all over delta T, right? All over delta T. Let me wait for you to finish writing this down. Okay. Now proceeding, you guys now see that F net is equal to M multiplied by delta V sub F minus V sub I all over delta T. So we're going to do this. Going to say F sub net is equal to M into V sub F minus V sub I all over delta T. Now, I need to ask you guys a question. Again, remember, this numerator, you have seen it somewhere, right? Yeah, so remember, M V sub F minus V sub I was equal to delta P, right? So we therefore say F sub net is equal to delta P over delta T. Okay, as you can see, this is Newton's second law of motion in terms of momentum. Okay, so this is Newton's second law of motion in terms of momentum. Okay, in terms of momentum. Okay, all right. So this is it, guys. Now let's state this Newton's second law of motion in terms of momentum. What does it mean? What is it? Newton's second law in terms of momentum states, so let me write it. Newton's second law of motion in terms of momentum, can squeeze it there. In terms of momentum, states the net force acting on an object is equal to rate of change of momentum. Okay, so this is an important definition that you need to know. Okay, Newton's second law of motion says, let me underline, okay, how can I underline? Okay, let me underline it in red, just so you may know. Newton's second law of motion in terms of momentum, it states the net force acting on an object, okay, the net force acting on an object is equal to the rate of change of momentum. Let's go back. Here is it. Net force acting on an object equal to the rate. When you say the rate of change, it means something is divided by time, right? So when you say the rate, it means something is divided by time. But in this case, because we didn't mention the rate of blah blah, we say the rate of change of momentum. So it is equal to the rate of change of momentum. In other words, it is equal to how momentum changes time. right? It is equal to how momentum changes per time. Okay, so that is it, guys. So please finish taking this down before we get to the examples, because I believe we are done. But I'm going to explain something before that. Okay, perfect. So remember, guys, we have said F net is equal to delta P over delta T. So what this means is that F net is directly proportional to delta P. What does this imply? This implies if F net increases, delta P will increase, right? Delta P will increase. And if F net decreases, delta P will decrease, provided time is kept constant, right? Provided time is kept constant. Okay. In the same way, let me go to the next page. F net, as you can see, is inversely proportional to delta T. What does it mean? If your delta T increases, F net decreases. If your delta T decreases, F net increases. You're going to see the application of this in the last video that talks about safety. Okay, when we talk about safety, you're going to see the application of this formula, the beauty of it. Okay, the beauty of it. Okay, guys. So this is, yes, this is momentum. Okay, this is Newton's second law in terms of momentum. So Newton's second law in terms of momentum says the net force acting on an object is equal to the rate of change of. Okay, that is. Now, let's get to the worked examples. Worked examples. Oh, this is item number 4. Examples. Example A, I will say 22-gram bullet strikes its target at 320 meters per second and eggs at 220 meters per second in the same direction, right? In the same direction. In the same direction. Now the question says, calculate the net force experienced by the bullet. Calculate the net force experienced by the bullet. Experienced by the bullet. Okay. Okay. So let me extract my data in our solutions. So to get our solution, oh, sorry, let me wait for you guys to finish taking this down. Yeah. Now, our mass, a 22 kilogram bullet, our mass is 22 grams, 22 grams. So 22 grams converted to kilograms, we can divide it by 1,000. This will be 0.022 kilograms, right? It will be 0.022 kilograms. Let me confirm. No, I don't have to confirm. It is. Okay. Now, they say it strikes its target at, so initial velocity is 320 meters per second, right? I will say into target. Okay, let me say into target. Into target. But is it right to say into target? Because, okay, let me say forward. Let me say forward. Yeah, I think let me say forward. Yeah, let me say forward. Final velocity was 220 meters per second. I will also say forward. All right, because let me show you a scenario here. Let me show you a scenario here. Oh, I think my information is incomplete. I should add, yeah. Okay, it's back. Okay, calculate the net force experienced. Let me add this, guys. I'm sorry. I'm gonna say the time here. If this thing takes 0.00015 seconds, okay? I'm sorry about that. Let me take that. Okay. Okay. So now the time taken was, oh boy, the time taken was 0.00015 seconds, right? So we are calculating the net force experienced by the bullet. It will be net force, because the formula says delta P over delta T. What is delta P? We know, we have said it's M times V sub F minus V sub R, right? Cool. So what is the mass? It was 0.022. Okay, 0.022. What else? Oh, I forgot to mention some. This is a vector calculation, so we should say forward direction is positive. So forward is positive, right? You should always state your direction when doing vector calculations. Okay? Now, what is the final velocity? It's 220 meters in the same direction. So since it's in the same direction, it's going to have the same sign. It's 220 because we said forward is positive. Minus, what is the initial velocity? Initial velocity was, oh, come on, man. Initial velocity was 320. Right here is it. 320 meters per second forward. So it'll be 320 meters per second forward. And the time is 0.00015. Yeah, 3 zeros. Let's get our answer. Yeah. 0. So my calculator says 0.022 times, I'm going to say 100 all over 0.00015. Right? The answer that we are getting is, okay, what is the answer that you are getting, guys? The answer that we are getting is 14,600 negative, right? It's negative 14,666.67. So this is 14,666,67 newtons. Where? You see this? This is the force exerted on the bullet by the target. I don't know what the material that the target is made of, but that target is exerting this force on the bullet, right? It is exerting this force on. Okay. Now, moving on. Let's now try this example. I'm going to try example B. It says a 900 kilogram buffalo. Those from Buffalo City, Sanbonani. A 900 kilogram buffalo is running. Oh boy, sorry. Let me know. It looks like I'm saying it's at running. So is it running at 6 meters per second? Is running at 6 meters per second towards a drop off. Toward a drop off. Okay. Toward a drop off ahead when it senses danger. When it senses danger. Alright? So what horizontal force must be, what horizontal force rather must be, or must the buffalo, not must be, must the buffalo exert to stop itself in 2 seconds? To stop itself in 2 seconds. Now this one is interesting because you're wondering, okay, so now there is no object that's changing momentum here, right? Or that's causing the change in momentum. Like in our all the times we've been saying that an object strikes something, but this time around it doesn't strike anything, right? Oh, interesting. But let's see. So our solution, we will say mass of the buffalo is 900 kilograms, is running at 6 meters per second towards. So I'm going to say initial velocity is 6 meters per second direction. It's okay to say what? Right? Toward a drop off ahead when it sees danger. Now, what horizontal force must the buffalo exert to stop its we see the word stop. So this means final velocity is 0. So final velocity is 0 to stop itself in 2 seconds. Come on. We can use Newton's second law of motion in terms of momentum, right? Good. So we'll say F sub net is equal to delta P over delta T. This is M into V sub F minus V sub I all over delta T. Now remember, I will say these are vector calculations. Toward is positive. Toward what? It's towards it's towards the drop off, right? It's towards the drop off, right? It's towards the drop off, all right? So what is the mass? Here's buffalo. Wow, it's 900 kilograms. Oh my, 900 kilograms. What is the final velocity? It's 0, right? Now what is initial velocity? It's 6 meters per second towards, right? Towards the drop off, so it'll be positive. Minus, remember, it'll be positive 6, right? Over, the time is 2 seconds. 900 times 3. Yeah, 900 times 3 must be 2,700, I think. Yeah. So our answer here is negative 2,700. But we are not done. Right? We are not done. This is negative. We said towards is positive. So our answer is simply, Fnet is simply 2,700 newtons where? Away. Right? Away from the, okay, away. Okay. So this is it. So yeah, guys, yeah. Yo, this buffalo. I'm scared already. Imagine a 900 kilogram buffalo. Oh boy. I don't want to live in the wild, eh? Okay, so with that being said, we aren't really done. We need to recap so that we can make a proper final calculations or final submissions, right? So let's see. Now, what we're going to do now is this, right? What we're going to do now is this. Let's see if we have answered the questions we asked. Let's see. Or maybe let's try to answer them. Let's try to answer those questions. How large is this net force? We are now able to calculate it if we are given tangent momentum and the time, we can calculate it. Again, we are also able to calculate this tangent momentum, right? We are also able to calculate this time, right? Now, we have also related Newton's second law of motion to acceleration, and I've also shown you that proportionality according to this law, right? Now I think we are good to go. We have answered all the questions, right? We have answered all the questions. So with that being said, I think it's safe to say ours ends here, and therefore we'll see you next time in the next video where we will be talking conservation of momentum. So with that being said, it's a wrap and bye.